Okay, we're going to go ahead and we're going to talk about our next type of experimental design, which is going to be blocking. Okay, so we're going to write in blocking. It's just a type of experimental design, and I'm thinking this is going to be pages 20 through 24. So we're going to turn to page 20 in our notes. Let me get that so you can see it. So first of all, some more details of experiments come in, and so there's some words that you may or may not be familiar with. So first of all, we have double blind. Okay, so if you don't know what blind is, first of all, that's when one group doesn't know what's going on. For instance, the subjects don't know whether or not they received a placebo or not. When an experiment is double blind, that means neither the subjects know or the person who is measuring the response variable knows. Okay, so that's a double-blind experiment. Now, what you're searching for in an experiment, the results, you want them to be statistically significant. Okay, that's when the difference in the responses is so large that it's unlikely that it was due to chance. Okay, a statistically significant association in data from a well-designed experiment does imply causation. Okay, so if it's well-designed and you get the difference you're looking for, you can get the cause and effect from that. And then the last thing, which is going to get more into what we're talking about, is a block. Okay, you can't control everything, so sometimes you need to use blocking. Okay, so that's when a group of experimental units that are known before the experiment to be similar in some way that is expected to affect the response experiment. Okay, so you're going to go with block. So we'll talk more about that later. So when you're talking about the experimental block design, first of all, you form blocks before experimental units are randomly assigned. Okay, and they're based on the most important unavoidable sources of bias. Okay, which has to do with the lurking variables among the experimental units. For instance, if I was doing something as far as like judging a new math curriculum, I might want to block by teacher because that's something that could have a great effect, the delivery. Okay, the next thing, the random assignment of experimental units to treatments is carried out separately within each block. Okay, so within each block, people would be getting both treatments. Randomization will average out the effects of the remaining lurking variables and also allow unbiased comparison of the two treatments. Okay, what this does, it reduces variability and any potential confounding that's going on. And then the last thing, by doing that, it produces a better estimate. Okay, so something's right here, you always control when you can, block on what you can't control, and you randomize to create comparable groups. This right here, so you have a little star, that's important. Control what you can, block on what you can't control, and randomize to create comparable groups. Okay, so I have some examples we need to go through. Okay, so for our first example, it says, suppose a researcher is carrying out a study of the effectiveness of 4 different skin creams for treatment of a certain skin disease. He has 90 subjects and plans to divide them into 3 treatment groups of 30 subjects each. Okay, it says if the experimenter has reason to believe that age might be a significant factor in the effect of a given medicine, he might choose to first divide the experimental subject into age groups such as 30 years old, under 30 years old, 30 to 60 years old, and over 60 years old. Then within each age level, individuals would be assigned treatment groups using a completely randomized design. Okay, so what would happen? Then our design would look something like this. You'd have your experimental units, and you would block. Okay, so my blocks would be under 30, 30 to 60, and greater than 60. Now, from there, what they went ahead and said in this is there's different treatments you could have. So then each group, we're not going to write them out, would get all of the treatments. And you would randomly assign those. And you would write randomly assigned treatments. So that's going to kind of give us a basic of where to start. Okay, so another way we could do a randomized block design would be to have subjects assessed and put in blocks of 3 according to how severe the skin condition is. 4 being most severe, and that's the first block, moderate cases in the second, mildest case in the third, and the members of each block are then randomly assigned to 1 of 4 treatment groups. So if you can go ahead and kind of give a breakdown for that, we can discuss that in class. Now, another example. Suppose you have 500 individuals, 250 males and 250 females, participate in a study for a new vaccine. Since it's known that men and women are physiologically different and react differently to medication, we might consider blocking by gender. Then with each block, subjects are randomly assigned. Okay, so that's an example of what might happen. Now, by doing this, the design ensures, okay, that was a stapler that just dropped. You can ignore that. By doing this, this design ensures that each treatment condition has an equal proportion of men and women. As a result, differences between treatment conditions cannot be attributed to gender. If you didn't do that, someone could use that as an explanation. The other thing, the randomized block design removes gender as a potential source of variability. Okay, and as a potential confounding variable. Okay, so that's the thing. You're using blocking to control the gender issue. Now, don't confuse blocking with stratifying. Stratifying has to do with samples when you're taking a sample. Blocking has to do with experiments. Okay, so the last thing we want to look at is example 3. Example 3 says, suppose that Apple Inc. is considering 2 different keyboard designs for its new model. Researchers would like to conduct an experiment using subjects who are frequent texters and subjects who are not frequent texters. The subjects will be asked to text several different messages in 5 minutes. The response variable will be the number of correctly typed words. Okay, explain why a randomized block design might be preferable to a completely randomized design for this experiment. Okay, so again, when it comes in, if you're doing this, there's some people who don't text a lot, and then there's people who text a lot. So that could come into play. So that's why you might want to use the randomized block design. And then what it says is to outline a randomized block experiment using 100 frequent texters and 200 infrequent texters. Again, so right here you can put, might be helpful to block by frequent texters versus non-frequent. Okay, that could be a lurking variable. Okay, so now we're going to go ahead and we're going to make this design. So I'm going to have 2 groups. Okay, so I'm going to block, I'm going to have 100 frequent texters and then I'm going to have 200 infrequent texters. Now I need to randomly assign. There's 2 different keyboards. That's what they're comparing here. So I need to write randomly assign. Okay, so they're randomly assigned. I had keyboard 1. $50 would go in that group, and keyboard 2. $50 would go in that group. Then down here, my same group, I have the 2 same keyboards. So again, you can see it's eliminating that bias by making sure some of each group is on each keyboard. So I would have 100 here, and I would have 100 here. Once I have that, I would just gather my data, pool it all together, and I would compare results.